Welcome back to the Learn, Serve, Lead stage. AAMC Board Chair, Dr. Lee Jones.
Good morning. What a tremendous performance and what a great way to start the morning, right? And all that talent. Remember, they're doctors too. They're musicians and doctors. Chris and Samuel, thank you so much for taking time from your busy schedules as a faculty and resident to share your musical talents with us. I have no doubt that we'll be seeing more of you, and attendees, you can say you saw them and heard them here first. We've now arrived at the very last plenary session of Learn, Serve, Lead 2024. This year's meeting is one I will not easily forget, and I hope it's the same for you. We, the academic community in medicine, have come a long way over just these past few days. I hope your conversations continue tomorrow, into 2025, and well beyond. Before we transition into this morning's session, I want to note that there is much more programming even after this plenary concludes. At 10:30, the breakout sessions will continue, including a Voices of Medicine and Society talk on the criminalization of medicine with Dr. Corbett-Helaire, a pediatric endocrinologist with Florida and a champion for transgender youth, and Dr. Caitlin Bernard, an Indiana OBGYN who in 2022 became a national lightning rod in the abortion debate. And don't forget that Dr. David Scorton will have a meet and greet in the AAMC Pavilion located in the exhibit hall from noon to 12:45 p.m. And now it is time for our final plenary. Throughout this meeting, our presenters have emphasized the necessity of a forward-thinking mindset, of being on the lookout for lessons learned, of seeking transformative change. During this closing plenary, I challenge you to believe that indeed progress has no limits. This morning's plenary will feature two such scientists who defied the odds in different ways, but in both cases, making a monumental impact on people all around the world. Their stories are sure to embolden us and leave us with a newly charged sense of discovery, an appreciation for the magnificence of science, and a drive to seek the unlimited potential in each of us. Leading this conversation will be AAMC's new Chief Scientific Officer, Dr. Elena Fuentes-Affleck. Elena spearheads initiatives that bolster medical research and training for physician scientists across all of academic medicine. She brings a visionary approach to addressing critical issues in research and science policy affecting medical schools, academic health systems, and teaching hospitals. Before joining the AAMC in June, Elena was professor of pediatrics at the University of California at San Francisco, chief of pediatrics at UCSF's Zuckerberg General Hospital, and vice dean for academic affairs at UCSF School of Medicine. Her scholarly work includes Latino health, immigrant health, and diversity in academia. Elena has held influential roles at national levels, including the presidencies of both the Society of Pediatric Research and the American Pediatric Society. She's a member of the National Academy of Medicine and the recipient of numerous awards, including the Joseph W. St. Jem Jr. Leadership Award from the Federation of Pediatric Organizations and the Lloyd Holly Smith Exceptional Service to UCSF. Elena has been active in several AAMC affinity groups, including the Group on Faculty Affairs, the Group on Diversity and Inclusion, and the Group on Women in Medicine and Science. Elena earned her undergraduate degree and medical degrees from the University of Michigan and a master's in public health from UC Berkeley, and completed her pediatric training as a research fellow at UCSF. Please join me in welcoming Dr. Elena Fuentes-Affleck.
Thank you so much, Lee. Good morning, AAMC. As a physician scientist, I can attest to the fact that research is a long game. Scientific discovery requires curiosity, creativity, and perhaps most importantly, persistence. Discovery is not mere serendipity, and experiencing failure today does not portend long-term failure. It's my privilege to introduce two remarkable investigators whose grit, resiliency, and persistence have made an impact on health around the globe. Dr. Kizzmekia Corbett-Helaire is a leader in the fields of immunology and infectious diseases. She is assistant professor at Harvard's T.H. Chan School of Public Health, the Schutzer Assistant Professor at Harvard's Radcliffe Institute of Advanced Study, an associate member of the Philip T. and Susan M. Reagan Institute, and the Freeman Hrabowski Scholar at the Howard Hughes Medical Institute. Kizzmekia is best known for co-designing the mRNA-based COVID-19 vaccines. Her research focuses on the advancement of vaccine and antibody therapies and the host immune response to coronaviruses and other emerging viruses. Kizzmekia is also dedicated to mentoring and advocating for STEM education and vaccine awareness in underserved communities. Kizzmekia completed her undergraduate education at the University of Maryland, Baltimore County, and earned her PhD in microbiology and immunology at the University of North Carolina at Chapel Hill. Our second speaker, Dr. David Fajgenbaum, refused to accept his imminent mortality from a fatal disease and instead immersed himself in medical data to identify a cure that was hiding in plain sight. David is a physician scientist at the University of Pennsylvania's Perelman School of Medicine. He's also the co-founder and president of two nonprofits, the Castleman Disease Collaborative Network and an organization called Every Cure. As a medical student who found himself battling a rare and deadly disease, David identified and repurposed a treatment that saved his life, earning him the moniker, the doctor who cured himself. David's innovative approach has led to the identification of 16 other repurposed treatments, which unlock the full potential of FDA-approved medications. He also serves on the FDA's board of directors for the Reagan-Udall Foundation. David completed his undergraduate education at Georgetown, a Master's of Science at Oxford, medical school at the University of Pennsylvania, and an MBA at Penn's Wharton School of Business. Let's take a moment to learn their backstories.
This Women's History Month, our new series, we're calling it Changing the Game, is profiling extraordinary women making an impact now and on future generations. As Beyonce says, who runs the world? Girls. This morning, we're going to introduce you to one of the pioneers behind the Moderna COVID vaccine. Her name is Dr. Kizzmekia Corbett. She's taken on vaccine hesitancy, and she's spent her career fighting for equality in healthcare, landing her a spot on the cover of Time magazine. You go, Dr. Corbett. The Bill and Melinda Gates Foundation provided funding for the studies that Dr. Corbett contributed to. Melinda French Gates has long admired Corbett from afar, which is why she chose her to be part of our series. Jamie Yucca sat down with both women at the nonprofit eBell that's in Los Angeles, which has a mission to educate and uplift women.
It's still very surreal to me. I still cannot believe we as a team did that.
I was told that I was one of the first people to open a vial of the vaccine.
At just 36 years old, Dr. Kizzmekia Corbett worked night and day with a team of scientists developing Moderna's COVID-19 vaccine in record time.
Why is Dr. Corbett a game changer?
Oh my gosh, she's an absolute game changer because when she was at the National Institutes of Health, she really laid down the backbone for the COVID-19 vaccine.
Being honored by people like you and having people say that out loud is certainly so surreal.
What's also surreal? Listening to Dr. Corbett's timeline once COVID-19 was discovered.
It was almost from January 6th on, no one got any sleep.
Have you slept lately?
I slept on the plane here.
All of us have now become familiar with the term global pandemic. Both these women say what motivates them is the dedication to improving people's health around the world.
Because we had a whole number of virologists and epidemiologists and had many, many, many partners in the field, we jumped on it to say, my gosh, whatever gets developed here needs to be done for the whole world in mind, not just the high-income countries.
Do you think we're going to get better about seeing those disparities and fixing that?
I was an undergrad when the HIV pandemic was in an uproar. And one thing that I saw was that it really only mattered what neighborhood you lived in. What we have to do is continue to keep the conversation open. Definitely. Because the same type of disparities that we saw with COVID-19, we saw with HIV, we've seen with so many other diseases.
Working toward equal distribution of the vaccine was just the beginning.
I hope you guys are rested and peaceful and healthy and vaccinated.
Corbett has spent the last 2 years encouraging anyone and everyone to get the shot.
You said something, you said vaccine hesitancy, and I know you don't like using that term.
I don't.
You like vaccine inquisitiveness. Why?
By calling them vaccine inquisitive, you give them the liberty to be the scientists, actually. Ask the question. Ask the question.
We are back with the story of a young doctor diagnosed with a rare disease, and with little hope for a cure in his lifetime, he set out to find one himself. Dr. David Fajgenbaum tells the story in Chasing My Cure, and Will Reeves sat down to talk to him about it.
David Fajgenbaum is an achiever and a fighter. As a college football star and an Ivy League doctor with a business degree to spare. But the fight of his life has knocked him to the brink of death 5 times.
So the first one is healthy David, and then there's sick David. But pretty soon thereafter became another, maybe a third iteration of me, and that was the one fighting back.
What were you thinking on the day you woke up?
I woke up in the middle of the night, and my sheets were just completely drenched from night sweats, and I didn't know what was going on. I remember going over to the bathroom and feeling my neck and noticing that I had these enlarged lymph nodes.
David was in his 3rd year at the University of Pennsylvania School of Medicine. He knew something was wrong and went to the hospital.
They said, David, your liver, your kidneys, and your bone marrow are shutting down. We're going to need to hospitalize you right away.
He was ultimately diagnosed with Castleman disease, a condition about as common as ALS, but much less known.
It's kind of like a mix between an autoimmune disease and a cancer. We actually don't even know which category to put it in. Castleman disease, at least my subtype, a third of us will die within 5 years of diagnosis. But I was so sick when I was diagnosed that I actually had my last rites read to me because the doctors didn't think I would survive.
David survived then and through 5 relapses.
I realized that I can't just kind of hope that someone somewhere would take care of finding a drug for me or push forward the science. If I wanted it to happen, I needed to make that hope into a reality.
Now with our series All In on AI. This morning, Rebecca's bringing us a look at its role in the medical field.
Hey, Michael, yeah, and it's a scary thing sometimes when we talk about AI, but it can also really help us. The technology is making its way into healthcare. It's allowing doctors to expand their research and helping create breakthroughs for patients. Dr. David Fajgenbaum was a 3rd-year medical student when his life was forever changed.
My only chance of survival would be to find a drug that was already on the pharmacy shelf.
It's called drug repurposing, discovering alternative uses for existing FDA-approved drugs. Now he's celebrating 10 years in remission. Throughout that time, making drug repurposing his life's work, co-founding the nonprofit organization Every Cure.
For 80% of drugs that are already generic, there's no research being done to figure out more uses for those drugs. We think there's a lot more potential.
And now that potential is further unlocked with artificial intelligence. Recently, Every Cure was awarded over $48 million from a federal agency to develop an AI-driven platform to revolutionize the future of drug repurposing.
So that way we can score and identify the most promising opportunities to treat patients as rapidly as possible.
It's just one major way that healthcare is implementing AI to rapidly expand research and more efficiently help patients.
And now, Dr. Kizzmekia Corbett-Helaire and Dr. David Fajgenbaum.
Welcome. Kizzmekia, David. Thank you so much for joining us. Your determination, your commitment is inspiring and a testament to what can be achieved when we embrace untapped areas of science. I'm going to ask a series of questions, and I hope that each of you will respond. First, we all know about the role of serendipity in the discovery of penicillin by Alexander Fleming. But Louis Pasteur famously noted that chance favors the prepared mind. I'd love to hear which factor you feel is most important in modern science, serendipity or preparation. Kizzmekia.
Well, I mean, the field of vaccine development that I work under is called pandemic preparedness, so I'd have to go with that. And I took the liberty of actually looking up the definition of preparedness, and the definition is to be prepared for in case of war. And I think that if you can train yourself, basic training, assemble your allies, do all of the things that someone in the military would do if they were going to war, do that in the case of your science, do that in the case of your medicine, you will have the mind that is ready to tackle any question that comes your way.
Thank you. David?
I love all of that, and I would maybe answer that I think it's a little bit of both, and it's the same with vaccines, but also the same in the work that I do, and also in my personal experience. I wasn't quite prepared to find a drug that could save my life. I certainly was not trained to be able to do that, but I experienced, I became sick with this illness, and I guess there was some serendipity to that, but then was able to really work really hard to try to find solutions.
Thank you. We celebrate scientific accomplishments and those whose ideas culminate in advances. Although our organizations, institutions, and faculty are all making efforts to diversify the scientific workforce, many of the scientists who receive major awards and prizes are white men. Knowing that the path to scientific breakthroughs, recognition, and celebrations is long, how can we inspire and encourage today's more diverse workforce? David?
Sure. I think the first thing is focusing on patients and patient impact, making sure that we are always squarely focused on helping as many patients as possible, and in addition to that, making sure that those of us that are able to push the front lines of impact, that we're bringing along and collaborating with a diverse group of colleagues. I have an amazing mentor in Arthur Rubenstein, and he has dedicated his deanship career to specifically mentoring leaders in academic medicine who are typically underrepresented to make sure that they can get to that next level.
Thank you. Kizzmekia.
You know, I like to think that the best inspiration that I could be is to just show up as I am. So I wear my leather skirt and I wear my lace-up sandals, and I exist as a scientist, but I exist as a human, and I exist as a Black woman first. And I think that what happens along the way is that more and more people who look like me, more and more women, my lab I think is like 70% women now, are just inspired to be a scientist, but not be the scientist that they're used to seeing on TV, but to just be who they are, ask the questions that are important to them, and exist day in and day out in my lab and labs all over the world just as they are.
Thank you. We all know that a necessary requirement for engaging in science is research funding. Individual investigators may not want to seek funding in unknown areas, or they may be reluctant to take unconventional approaches to their work. How have you juggled the various approaches to science, placing existing methodology at one end and unconventional approaches at the other? And what type of advice have you received about how to approach your area of inquiry? Kizzmekia.
Oh, wow. Oh gosh, you're asking this question from the person whose one criticism on their associate's package for professor was that I don't have NIH funding yet. But I'm doing all right. And the reason why I think that I do okay is because I let the science lead. I ask the question, and then I go say, which foundation or which organization would be interested in this type of question, and I write my grant based on the question. And the reason why I don't have NIH money is, well, the secret is that they have 450 some million of my money, so I feel like I should get some back. But I haven't worked up the nerve to ask for about $1 million back yet. But no, the truth of the matter is that the type of questions that I have tended to ask throughout the course of my career, and specifically in my lab, are the questions that are outside of the box. So I started in coronaviruses, and now I'm working on a virus that hasn't even infected a human yet. It's only infected African monkeys, and actually just left Africa, came here from Africa. And then I started asking questions about how we can go under the algorithm on Instagram to target moms who are vaccine hesitant. I allow the science to drive the way, and then I promise you, if you do that, there is a foundation somewhere that is very interested in answering that type of question. You just have to dig a little deeper than what is stereotypical for the way that we get funding. So, for example, my Instagram post that people like, the Ask Kizzy series, is funded by Mark Zuckerberg, right? Because he's interested in his algorithms and social media and how you can use your face to drive home messaging on social media. And I think that for now, that works for me. And I find also that there is far more money out there for science and medicine, particularly biomedicine, that than any of us could ever get. It's not always with the NIH or the NSF.
Thank you. David.
Sure. I totally agree, and I think that a couple things have guided me as I've been on my journey. So one is that the traditional way of doing medical science, as was mentioned earlier, is to come up with a really great idea and then to apply for funding for that really great idea. And that works really well, or tends to work pretty well for the NIH, where they get thousands and thousands of applicants and they can pick the best application out of all of them. But it doesn't work really well for, say, a rare disease, where maybe there's only a few people who know anything about that rare disease. And so one thing we did for Castleman disease was to say, we're not going to take this RFP approach that's typically used. We're actually going to go out and we're going to crowdsource from all the physicians, researchers, patients, and loved ones what research should be done, what research questions need to be asked. And then we could go out and we could find the best people in the world to actually do those studies. And that frame shift from this sort of, each of us comes up with an idea and we apply for funding here or there, towards this more collaborative and comprehensive approach where patient voices, loved one voices are actually at the table telling us what we should actually do, has really been a game changer for Castleman's. And then the other thing, again, focusing sort of end in mind, that we've done that's been a bit different is focusing on repurposing drugs. So when I became sick with Castleman's, I didn't have $1 billion in 10 years to develop a new drug from scratch. I knew that if I wanted to survive, I would need to find an existing drug that was already out there and see if I could repurpose it for me. And we were able to do that successfully for myself, but we also have now been able to uncover over a dozen other drugs for diseases that they were not intended for. And so it's, again, this staying focused on the science, what's important, how can we make the greatest impact, and let's do it in a simple way. If you don't have $1 billion in 10 years, but you've got a bunch of drugs in the pharmacy shelf that could help people, let's go after those ones.
Thank you. The stereotype of a scientist is a solitary eccentric, most typically a man. In today's world, however, we recognize that science is a team sport. What are your thoughts about the continuum from individual investigators through teams of scientists? What are the advantages and disadvantages of these approaches? And what is the role of technology, or AI? David.
Sure. So I don't really see there being a continuum from team science to individual science. I think it's all team science. At least in my lab and with my collaborators, it is always team science. And so we've been collaborating with folks from around the country, but also just the key members of our team. Everyone plays an important role because we tackle questions where no one has the answer to those questions. So by definition, that means every single one of us can contribute to getting to the answer. I also like to think about anytime you face a difficult challenge as needing three things. And I sort of go back to when I was in the ICU, and I remember staring out this window in my ICU room and dreaming about a future. I wanted to have a family. I wanted to conduct research. I wanted to take care of patients. And I remember grieving that I wasn't going to be able to do those three things, that I was going to die from this horrible condition. But I had this vision for what I wanted so badly. And I remember the second thing I had was I had my sisters and my dad by my side supporting me. Dave, just breathe. You can keep fighting. That sort of teamwork support was critical. And the third step was taking things one step at a time. And thankfully it was one breath at a time and then one drug at a time. And now it's been over 14 years since I was looking out of that ICU window dreaming. And I think that sort of framework of having a vision for the future, having support by your side, and then taking things one step at a time, I think that's the framework that we need to take on diseases, but I think it's also the framework that we need just to take on tough challenges.
Kizzmekia?
I would largely agree with everything that he said. And the one thing that I said around the pandemic and the team that we had amassed during the pandemic, actually before the pandemic, the large network of collaborators is who wants to save the world alone? Like, what a huge task, right? When you think about it that way. And the truth of the matter is the way that we have typically trained scientists is in my example is I'm a viral immunologist. I think about the immune system, but only in the context of viruses. I think about viruses, but only in the context of the immune system. And if you ask me what like a T cell does, I would like scream because I don't really have an idea because I only understand B cells and antibodies. But there's someone who understands T cells, and I should partner with them if I'm going to make the best vaccines, right? And I learned that very early on because there was really no way for any one person to know everything. And I also take kind of what is the framework of my own family and overlap that with my lab and my collaboration. So I have 6 siblings. We come from varied backgrounds, foster siblings, adopted siblings, step siblings, and et cetera in my household. And so you might imagine that might cause a little bit of rift sometimes. Sometimes we aren't the best of friends. And I remember my therapist saying to me once when I was talking about my family, she said, you should think about, I always thought, oh, I'm doing everything. No one ever contributes the way that I contribute, right? But she said, you need to think about how they contribute. Everybody is contributing something. So I went home for the holidays and I literally wrote down what each individual contributed. And it turned out, even though I couldn't necessarily see it, the small pieces of the puzzle really helped the holidays to go smoothly, and everybody was doing something. And I think about my lab in the same way. No one person is the head honcho, even myself. I only hire people who are smarter than me. I only hire people who are not viral immunologists because I feel like I could do that part. And we tend to do science that is bigger in scale, even though we're a small group, because of that.
Thank you. Everyone experiences failure. One of my mentors told me that to be a good researcher, you have to be a good loser. How have negative findings influenced your career? We know it's nearly impossible to publish a study with negative results, but there's value in knowing what doesn't work as well as knowing what does work. Do you think science and scientific publications should take a different approach to negative results? Kizzmekia.
Well, I will say that it's even very hard to publish positive results these days, but I'm struggling to get some publications out as we speak. But I think that overarchingly, let's not think about it from the context of negative and positive. I think that the one thing that I did a lot in the pandemic that was great, but the one thing that I am remiss on is that I got on TV in like April 2020. I'd been working on vaccines for coronaviruses to that point 5 years, and no one knew. I thought I was the hot SHIT, right? Because I had publications in Nature and Science and all of these great magazines, but no one in the general population knew that these types of vaccines were on the horizon. No one knew that we'd already put mRNA in multiple different animals. It had been in people in the context of cancer, and et cetera, and et cetera. And that's because we only were thinking about our publications in the context of scientists and medical doctors and how we could feed the field, but we were not necessarily generating knowledge for the general public. And so now what I think is going to be more and more important, especially because things are moving quicker with AI and with all of these advancing technologies, the different types of ways that we do experiments, science is moving so fast that before you can even get something through a reviewer's hands and into a publication, the next thing has happened. And so what's going to be more and more important is that we try our best to make knowledge public no matter how bad it looks. I think that for me, what that means is that I tell people about my science as it comes out on Instagram, and many people are trying to do the same thing with various social media channels, but whether it be preprint, whether it be press release, whether it be whatever your medium may be, I think it is very important that we not necessarily gatekeep scientific knowledge, negative or positive, for journals, but more so thinking about it as this is our way of informing the public. This is a way of informing the world of what's to come.
Thank you. David?
I totally agree. And I have a really practical example for why it's just so important to get out these negative results. So I recently launched a nonprofit called Every Cure, and we utilize an artificial intelligence platform to predict the likelihood of every single FDA-approved drug, all 4,000 of them, to be able to treat every single human disease, all 18,500 of them. So if you were to try every drug for every disease, you would have 75 million shots on goal. And we utilize this AI platform to come up with a score from 0 to 1 for how likely every single one of those drugs for every single one of those diseases are. And so in order to be able to come up with those calculations, we have to train algorithms on known treats relationships. We know this drug, siltuximab, treats Castleman disease by inhibiting interleukin-6. We build biomedical knowledge graphs that have all of the world's biomedical concepts in them. We train algorithms on known treats relationships. Well, to do this really well, you need to also be able to train algorithms on known don't treats relationships, on examples where the drug does not work for that disease, but because of this bias towards not publishing information about negative results, the algorithms don't have as much material to work with. We have about 4 times as much material to train the algorithms on treats relationships to not treats relationships. But fortunately, these algorithms are still able to come up with really impressive predictions around the likelihood of every drug to treat every disease. And the important thing is we use it as a signal finder to then actually run the clinical trials to prove out that these drugs work. So it hasn't been a fatal challenge for this kind of work, but I think we all know that artificial intelligence is coming, it's here, and these sorts of uses of AI are going to be completely life-changing and game-changing, but we need these negative results to train algorithms.
So what do you do in the case that your algorithm does spit out a negative result?
So, well, it gives a score from 0 to 1. So it's giving a lot of quote unquote negative results for the vast majority of drug disease matches, and that's okay because we are very excited about drug repurposing. Of course, I'm alive thanks to a repurposed drug, and we've saved a lot of lives with repurposed drugs. But we know that not every disease is going to be able to be treated by a repurposed drug. We know that not every drug out there can be used in myriad more ways. But I think it's about getting closer, to your point, getting closer to truth. And in order to get closer to truth, you have to know the positive stuff, we also have to know the negative stuff.
Thank you. The path to a career in science is long. We have collectively here with us the community of academic medicine leaders. How could academic medicine improve the way we prepare and support aspiring researchers, including PhD researchers and physician scientists? David?
I think that, first off, AAMC does an incredible job bringing these various communities together, diverse communities together. I think that all of us have to do our part. We have to do the one step at a time. So it's engaging that young person who's interested in maybe going to a career in medicine, who maybe needs that little bit of extra support. I think it's all of us taking on our small areas of this puzzle, and I think we can make a really big difference together.
Kizzmekia?
This is very hard. I can see several places where we could certainly do better. I think for me as a scientist, the one thing that I like to champion is this fellowship or this traineeship level where you're a professional but you're not really paid, so you can't be an adult. In the same sense that your friends on Wall Street are already adults, so to speak, at least financially. And it feels like school again, and that's okay because you're being trained, but at the same time, you're not really valued by people who are more mature in the field than you or people who are training you. And so there are little small things that can help. And so a lot of universities now are, instead of calling their postdocs fellows, they're calling them scientists. So a postdoc scientist. So now it's like the equivalent of a scientist one, which would be in the industry, for example. Everyone's trying their best to inch their way up the scale for paying postdocs now. I think more and more Stanford kind of leads the way, I will say, but more and more universities on the East Coast are trying our best to pay postdocs more. And then I think the other thing that is going to be more and more important, especially as we think about the hierarchy in a laboratory, is really understanding that those positions they are training positions, and the point of them is so that that person leaves. Which is a hard pill to swallow when you have someone who is really fantastic in your laboratory. I'm dealing with that now, right? I have people who are at the point where they should be going off to get their own faculty positions, and I just want to keep them a little while longer. But we really have to think about these positions as stepping stools and not places where we hold talent and house talent such that we are building more and more from the top.
Thank you. We think a lot, particularly at this phase in history, about scientific knowledge in the population. And some people say that there's a lack of scientific knowledge in the general population. What are your thoughts about the level of awareness of and knowledge of science in the US population? And if you think we need a change, how can we, as the community of academic medicine, advance this goal? Kizzmekia.
I think what we're going to have to do, oh man, it's like 2,000 of you in here, so don't hate me. But I think one thing that we're going to have to do is come off of our high horse. I think we have defined science based on what we know from the ivory tower with our PhDs and with our MDs and with our Ivy League jobs. And I think that is absolutely unfair to the layperson. Because I like to think, especially as a young girl from Hillsborough, North Carolina, I like to think I was a scientist since I was about 16, the first time I stepped into a lab, even before, quite frankly. What science is the ability to ask a question about why the world turns in the way that it turns, why nature is the way that it is, and to be able to strategically answer that question. And the way that we think about it is by going into the clinic or going into a lab, and that is our strategy. But everyone's strategy is not going to be that, and we're going to have to honor other people's strategy and make sure that we redefine science in order for science to continue to be trusted, in order for the medical institution to continue to be trusted, and moreover than that, in order for us to be able to take our science down to the language that other people are speaking, and for us to understand the way that they're speaking their science. And so my first thought is that maybe we've over-defined science, which is okay, but it's time for us to pare that down just a little bit and respect the layperson as the scientist in their own right.
David?
Yeah, I completely agree, and I think that I shared an example earlier where we do this crowdsourcing effort where we turn to physicians, researchers, patients, and loved ones of patients to determine what research should be done. And we were so thrilled when we did this the first time to find so many different research questions and challenges that patients and loved ones were bringing to us than we, the scientific advisory board for Castleman's, were bringing to the table. There were so many different perspectives, so many different research questions that were being brought up, and these are the things that meant the most to them. And we also involved patients, and I say them, but I'm also a patient, of course, so we brought them forward and helped to prioritize what research should be done. And it just highlighted that for so long, at least within Castleman disease, we as a scientific community are deciding what research should be done, who should do it, and we weren't actually including patients and their loved ones in the decision process. I think that that's a microcosm for our broader scientific community, and I think there's a lot more we can do to involve the people who can benefit from our medicines into the fold much earlier on. And another way that we're trying to turn that into practice with this nonprofit EveryCure is creating a place on our website, everycure.org/insights, where patients, loved ones, and physicians can share examples of drugs that have been repurposed for them. Rather than just relying on this AI algorithm to come up with predictions for new uses for medicines, can we also turn to the community and understand, what was that drug you used off-label to save that patient in the ICU? Can you share those insights with us so that we can proactively pursue those? And the last thing I would share is to share examples where the science worked and where our science saved lives. I mean, obviously the vaccine is just such a great example that we all have been able to see. But we recently utilized our AI algorithm, actually for the first time ever, we ran it 2 years ago, to predict the first ever use of a TNF inhibitor for a patient that was in the ICU and getting ready to be transferred to hospice care. And amazingly, that TNF inhibitor saved that patient's life, and Alan didn't have to say goodbye to his daughter or his wife and is still with us now. It's almost 2 years later. And sharing those examples where science got it right, where AI algorithms actually can make useful predictions, I think is one way to bring our community along with us.
Thank you. You're weaving together many of the themes that we've discussed here in terms of communication and trust and listening. So thank you for that. Given the long-term nature of scientific discovery, how do each of you sustain your energy and enthusiasm, which we can all feel? There's no prescribed path to making an impact in science, and while the highs of a career in science are incredibly meaningful and impactful, a career dedicated to science may not be a good match for someone who needs results as motivation. How do each of you keep yourselves motivated? Kizzmekia?
Oh man, I just wrote about this for the Journal of Infectious Diseases, and I think I titled it 5 Lessons of Resilience, because that's essentially what you're asking. How are we resilient in this field that is almost innately built to tear you down? Failure is the cornerstone of what being a scientist is. And I think the hardest lesson for me to learn is that rest is important. And I think I didn't learn that really until I was forced to, because I married a man who refused to let me work more than I loved. So, and when we went on our honeymoon last December, it was literally the first time I'd ever gone somewhere and not taken my laptop with me. And it was also the first time that I came back with a fresh enough idea that started an entire program in my lab. And it made me realize, wow, resting my brain is really important. And so more and more as I mentor, the one thing that I like to remind people is that rest also looks different from me to you, probably to you. So what it looks like for me at this stage in my career is delegation. I was told I was far too junior to have an executive assistant, but I also get 400 emails a day, so why not? So having to learn that it is not my burden to carry all the weight of all the things that come my way, that delegation is okay, and that I do not have to do everything, but only the things that speak to my expertise has become more and more helpful for me.
Thank you. David, how do you sustain yourself?
Sure. For me, I get this tremendous motivation from each of the patients that we're able to help. So when I'm able to hear the stories of patients who get a repurposed drug and their life was saved when they otherwise wouldn't have been if we hadn't come up with that new opportunity. And that really motivates me. But then, of course, what really motivates me are the patients that we weren't able to help in time. When we hear stories of patients where there wasn't a drug for their disease and we searched so hard and we worked so hard to try to find something for that condition and we weren't able to. And of course, I bring myself back to being a patient myself, and I lost my mom to cancer almost exactly 20 years ago, which is what first got me into medicine in the first place. And reflecting on not just the patient that's lost, but the loved ones around them just drives us so hard. It's the patients we help and the patients that we can't help today that drives us to work for more solutions tomorrow.
Thank you. Thank you both for this incredible conversation. I'm very inspired by your commitment to innovation and research, and I'm sure that the lessons you've shared are resonating. We're now going to transition to the audience part of the session. And in advance of this session, we invited you to submit questions for Kizzmekia and David. And I'm going to share as many as I can in our allotted time. Beginning with, as the pace of scientific discovery accelerates, how do you think we should balance the pursuit of rapid innovation with the ethical responsibility to fully evaluate the implications of new technologies, especially in areas like AI and genetic engineering? Kizzmekia?
Oh, this question is probably really great for me, considering I had a vaccine that was so rapidly developed. Right. So the one part of that question that really sticks with me is implications. And are we talking about implications on, obviously most likely talking about implications on the patient? And most of the time when people ask that question, they're talking about what the negative implications that are side effects for what we think is something really positive, like a vaccine or another therapeutic. And I think what we have to do is continue to follow the science. And in the case of vaccines, for example, or even antibody therapies, which is something else that I developed, the science never stops, even after the drug has been deemed appropriate, effective, and safe for human use. And continuing to follow the science allows for us to do things like, for example, the recent RSV vaccine, which was approved for people over 50, in the last year just got reapproved for people only over the age of 65 because it was deemed that it was not necessary for people between the ages of 50 and 64. And I think as long as the science continues to be followed, we won't have a problem with so-called, at least in this case, what I think they mean by negative implications. And the one thing about AI that is the undertone of everything that comes out about AI is that we have to remember, just as David said, is that for every one piece of positive information that comes or that is fed into the AI algorithms, there's dozens of negative pieces of information. So AI is learning on the negative as much as it is learning on the positive, even though the negative isn't what is necessarily reported. We learned that in the case of how we use AI in my laboratory, which is to try to understand which disease or which viruses might jump into humans next, right? So we think, oh, it says X, Y, and Z virus might jump in 100 years, but what about all of the other viruses that it didn't tell us about? It actually did learn something about those viruses, and what we aren't reporting are all of those other negative things that AI is learning. And so I think that we have to kind of continue to remember that as we think about what the implications of AI are.
Thank you. David?
Sure. So the work that I do in finding new uses for old medicines is maybe it's counterintuitive to think about how rapid it is because these drugs have been approved maybe 50 or 70 years ago. But they're rapid in the sense that we can make a prediction that a drug might work. We can maybe do some validated work in the lab. And we can get drugs into patients in a matter of weeks because the drugs are already FDA approved. We already understand how they work. We know their safety profiles. And importantly, they're already at the neighborhood pharmacy. Also importantly, of the 4,000 FDA approved drugs, over 80% of them are already generic. So that means there's no financial incentive for anyone to find new uses for these old drugs. So there's a lot of these great opportunities that are just sitting there. And we oftentimes are able to uncover that one of these old drugs that's sitting on the shelf could actually be life-saving for a patient today. And so in those cases, the cases where patients are gravely ill and they're on their deathbed, we're able to try those drugs, and oftentimes they work and they save these patients' lives. At the same time, we can use these algorithms to find promising opportunities that have been generally neglected. So I'll share a couple examples that recently scored highly in our algorithm. One of them is for a drug called leucovorin in autism spectrum disorder. It turns out that a substantial proportion of children dealing with autism have a cerebral folate deficiency due to autoantibodies against the folate receptor. So they're functionally not getting any folate into their brain, but if you give high-dose leucovorin, you can actually get something called folinic acid through a transporter, and then now you functionally get folate into the brain, and there have been 3 relatively small but randomized controlled trials demonstrating increased verbal communication skills and a number of other symptoms. So it turns out that actually a notable proportion of children dealing with ASD actually just have a folate deficiency, but this cheap old drug leucovorin, which has now been studied in multiple clinical trials, is not being taken up in part because it's a cheap old drug, and there isn't a path forward for cheap old drugs to be used in new ways. We also recently came across really strong signal around peritumoral injection of lidocaine into women with breast cancer. Large randomized controlled trial of 1,600 patients found that if you inject lidocaine directly into a tumor 7 to 10 minutes before surgery, you'll have a 30% relative risk reduction in mortality at 5 years, which is an absolute risk reduction of about 4% in overall survival, which is just huge. But of course, there's no big emphasis behind selling more lidocaine, and no path forward to commercializing something like that. So opportunities like that literally hide in plain sight, and that's why Every Cure exists, is to unlock these opportunities hiding in plain sight that oftentimes just aren't being unlocked because there isn't a commercial path forward, and then get them to patients really, really quickly.
Thank you. The next question takes us back into the academic world. We talk here a lot about mentorship. We celebrate mentorship. You highlighted, David, your relationship with Dr. Rubenstein. So the question is, what is the role of mentorship in scientific discovery? And do mentors sometimes stifle creativity? David, we'll turn to you first.
I think mentorship is just so critical. And I think that what I've learned is that mentorship is a two-way street. Your mentees teach you just as much as you do, and vice versa. And I think there's always opportunities for informal mentorship, showing people how to do things the right way versus more formal mentorship. And I just think it's absolutely crucial. I have to mention Arthur again. I first met Arthur when shortly after I became ill with Castleman's, and he was setting up the Orphan Disease Center at Penn, and I supported him with that. And then I had this horrible relapse where I learned there were no drugs left for my disease. And I went to Arthur, I said, Arthur, I'm going to take on Castleman's, and I'm totally terrified. I don't know how I'm going to take this disease on, but I'm going to die in the next few months if I don't find a drug. And I said, Arthur, will you support me? And he said he would. And he has met with me every Monday for the last 12 years. I've met with him literally weekly, and I've turned to him with every challenge that I've faced, every uncertainty that I have, every fear I have about this experiment or that experiment or this project or that. And he's helped to share, decades of experience with me to help me to come up with these solutions. And so you can imagine this idea of paying it forward. All I want to do is support and mentor the next generation of people, my generation, help in any way I can, because I'm literally alive today because I was able to benefit from support and guidance in the way that Arthur provided it.
Kizzy?
I think, so I've had the most amazing mentors throughout my career as well, whether they be my first mentor when I was 16 years old, all the way through now, the chair of my department, Dr. Sarah Fortune at Harvard. What I will say in regards to, can a mentor stifle creativity? The truth of the matter is that it is possible for a mentor to only see in you what they can see in you. So I don't necessarily think it was in anyone's vision of me that I would be doing science on science communication, or publishing articles on science communication, and actually trying to undermine algorithms on social media. Like, how wacko for a virologist to be doing that, right? And so what's important to understand about the mentor to mentee relationship is that as you grow with your dreams, it is also okay that you grow your mentor network so that your dreams can grow as well. Because it would be impossible for my basic science department chair to mentor me through understanding science communication, because she's never done that, and this isn't what is in the purview of her department, and that is okay. So learning how to reframe your dreams and to tack the right types of mentors on top of those dreams is so important for your dreams to grow and for you to grow as a person.
Thank you. I'm sure all of us who are mentors are thinking very carefully about what you said. Thank you for that. For decades, people have described physician scientists as endangered, an endangered species. Do you agree? And if so, what should we do? Kizzmekia?
Oh, I think this is for, I'm not a physician scientist.
You don't want to open.
And I'm okay with, no, I'm just kidding. I want everyone to be just a scientist, so I'm okay with that.
Okay. David.
I think that there certainly is something to this. We have seen some of the most brilliant minds in science, and physician scientists in particular, move more into industry roles than in typical academic roles, which I don't think is a bad thing. I think that we need to be developing great new drugs, and we need really brilliant minds within industry. I think that it's about figuring out how do we still maintain really strong physician scientists in academia. At Penn, we've been able to see a number of physician scientists who can sort of straddle between the clinical world and the scientific world, be able to take breakthroughs through to patients, things like CAR T-cell therapy and gene therapies, and certainly involvement in RNA therapies as well. So I think that there's a real important role for intersectionality and being able to look across industries and even across spaces. So I think we need to figure out ways to keep physician scientists within academia, but I think we also need to celebrate when those physician scientists do go into industry and they're a part of developing amazing new therapies.
Isn't there a pipeline burst, so to speak, earlier than that though? Like on the way to training?
I think so. I think that a lot of people don't know that there's a physician scientist option. I think very few people actually realize that you can be both an MD and a PhD, and so I think that there's definitely a burst early. I think that that it's fully covered by the federal government, so it's extremely competitive, the few spots that do exist. And I think there's more that we could do, yes, early in the funnel, and then I think that you're right, the leaky part at the end maybe isn't the biggest problem, maybe it's the issue at the front. It's a great point.
I would only add that I think when I think about physician scientist, of course we traditionally think about MD, PhD, but I think there are many of us, including many in this audience, who are physician scientists who do other kinds of science. And so it's a broad field, and right, you and I both. And so we are contributing to science. But I think the pathway, as we've said, is long, is complicated, and I'm sure many of our attendees are drawing inspiration from your thoughts. Let me go back to scientific discovery, and I want to say thank you to everyone who submitted questions. These are fantastic questions. Scientific discovery is generally incremental. What are the keys to achieving breakthroughs and moving beyond incremental discoveries? Kizzmekia.
So I absolutely do not think I do incremental science.
I didn't say that.
And no, I was framing it that way because I think that there is a space for the scientist who does not necessarily do incremental science. Obviously, we do it logically, we do science logically, but thinking about what the next 3 major experiments are such that we can frame our work that way is not the way that we necessarily think about science in my lab. And I think more and more people are thinking about big data type of science. And was the question, how can we move in that direction, or how can we?
Well, that if generally scientific discovery is incremental, is there something we could do to push non-incremental breakthroughs?
Yeah, I think funding, hands down, really the only way that we're going to get more and more scientists to think outside of the box, outside of incremental type of science, is to provide funding that funds and leaves us alone. And I say this all the time in front of foundations, but what is so important is not to fund a scientist with an incremental chunk of money and then in a year ask, what have you done such that you can get your next chunk of money? And then what have you done so you should get your next chunk of money? Say, I'm going to invest in you as a scientist. I know that you have really great ideas. Here's a large chunk of money. Go to work, and I'll see you in 5 years when it's time for your next large chunk of money. This is what is the Howard Hughes Medical Institute model. And while it does take billions of dollars to do, there are people with billions of dollars who have the ability to do that, but it is almost a hands-off approach and allowing people to think freely, which I think is going to be more and more of the wave of how science is going to be done in the future, especially because by the time you can even think about what your next increment is, someone's already done that experiment. So for me, especially as a coronavirus virologist or viral immunologist, by the time I think about what my next antibody is, I'm getting a paper to review that someone has discovered one that is very similar. And so I had to say to myself, what's next? And not what might jump into a human tomorrow and cause a pandemic. What might jump in 50 years? That's what I need to start working on today. And that is the type of science that is not funded in an incremental way.
Thank you. David?
Yeah, I totally agree. And I think that in my case, I really always like to think about what is the thing that we're working towards? What's that vision for the future? What's that thing that you might be looking through that window to imagine? And for us and for our lab, it's always around patient impact. And how can we help the most patients as rapidly as possible? And I think that a lot of times in medicine, we see the sort of the short-term goal, which is like a publication in a high-impact journal or getting a grant. But those really are just in service of or reflections of either good science or good ideas towards that eventual goal. So I think that in medicine, I think we can try to focus a little bit less on the high-impact journal, because that's just not the end of the road. I mean, I certainly have colleagues where there's celebrations around publications, and there should be, because that's an important milestone, mile marker, but that is not the end of the finish line. That's not the finish line by any means, and I don't think it should be, even if maybe that's the end of where your lab is going to be particularly useful. Help to find the next group, help to find the clinical trialist who can do the trial of the important drug you just found to be effective in mice, help to move it to that next step. So I think if we can just stay really focused on that mission, that thing, the patients, the impact we can have, and then I think that'll help us to focus a little bit less on these, mile markers along the way.
Thank you. I want to turn to the theme of hope. And David, your story, your book talk a lot about hope and what hope can mean. And it can be passive. We're hoping for something to happen. We're hoping for our experiment to work. We're hoping to hire someone. Or hope can be active, where we are acting to bring around hope. So I want to ask each of you, which will probably be our final question, what are you hoping to contribute, to achieve? What hope do you have at this point in your careers? Kizzmekia.
For me, I think, I've achieved most of what I would have said I would have liked to achieve in science. And so now I'm making up bigger and better goals for myself on the scientific front. But the one thing that I do not think that I have achieved is I like to think of myself now as the world's vaccine teacher. And I want as many people as possible that I come in contact with to be able to understand just the basis of how vaccines work. And I am hopeful for a future that is vaccine literate, essentially.
Beautiful. David.
The thing that really drives me is this major gap between the drugs that we have, those 4,000 life-saving precious molecules, and the patients that are suffering right now who could benefit from those molecules. And there is just a tremendous amount of opportunity to find new uses for old medicines. We in our lab have done this over a dozen times, finding a new use for an old drug and saved thousands of lives. But the reality is there are thousands and thousands, maybe even millions more lives that can benefit from these old drugs. And so the thing that just drives me every day is how do we bridge this gap between the solutions that are right there within reach and all the people out there that can benefit from them. And as you mentioned, this concept of hope. And I think hope can sometimes be very passive, as was mentioned. I hope that this is going to work out. I hope that I hope that this drug, maybe could help some patients. But if we can all reflect on what we're hoping for, we can say, what is it that I'm hoping for today? What am I wishing for? What are those things I'm hoping for? And then ask ourselves, what can I do today, tomorrow, and the next day to get closer to that thing we're hoping for? I think we can all get closer to that vision that we're all working towards. And for me, that's going to be trying to find as many life-saving new uses for existing medicines as possible.
Kizzmekia and David, thank you for the work that you do. Thank you for sharing your insights and for leading this important and inspiring conversation.